Hello everyone, welcome to Olsen Cafe. Today, I would like to talk about completing the square. This is a topic many students often frown upon. So today, I hope to give you a visual guide of what completing the square really means. At the end of the video, I hope you are able to see the patterns and realize that completing the square is actually not that tough at all. You just need to see it. So let's begin. Now, so let's take a look at the first example, complete the square. So over here, I'm going to use x squared plus 4x to illustrate. So using diagram, so what it simply means is that x squared actually represents the area of the square. All right, so whereby I have the sides x times x, so this gives us x squared. Now let's take a look at the 4x. So this 4x, I can simply split it, all right, to form 2x times 2x. So this will give us x squared equals to 2x plus 2x. Now, what I would like all of you to observe is that this itself, right, should actually make it into a perfect square. So what is missing, you notice there is this little space here. So what do we want to consider, right? The meaning of to complete the square, it is simply to ask ourselves this question. That is, what constant term do I need to add to make this diagram a perfect square? Yeah, so using this, all right, we can see that this is the missing piece. So with this missing piece, all right, then I will be able to form the area of the big square. So this itself, the sides will give me x plus 2, and with the sides x plus 2, and therefore this will give us x plus 2 square. So let's take a look. So this itself is x squared plus the area of this rectangle, which is the length here is x, and then the breadth here is 2. So using this area of rectangle, this will give me 2x plus 2x, which gives me 4x. Now, how about this missing piece? What is the dimension of this missing piece? So if you take a look, I will have this, which is 2, and the other side it is also 2. So therefore 2 times 2 gives me 2 square. So what is good to observe, all right, it is also this number 2 here. You notice that this number is actually the half of the coefficient of x. So therefore later on you will get to see the patterns, right? Each time for us to complete the square, we will need to add on this term, which is half of the coefficient of x. Hopefully this gives you a good visual representation what completing the square simply means. Now I'm going to use different approach to illustrate to you, so hopefully you get a better understanding of what completing the square means. Okay, so over here, let's take a look at another example. So again, we are going to complete the square for this diagram. So you notice that there is a missing piece. Now, so for this diagram, what we have here is we have area of this square, which is x squared. Then we have area of the rectangle, which is 3x. So again, with length, which is x, multiplied by the breadth, which is 3. So 3 times x, so therefore give me 3x. So again, I have area of the other rectangle, which is also equals to 3x. Now, so this will give me x squared plus 3x plus 3x. So this actually give us x squared plus 6x. Now, so what it simply, all right, refer to is to complete the square, we will need to find what is the constant, which is this missing piece that I need to add to make this x squared plus 6x a perfect square. So to do that, all right, I know that I need this missing piece, right? So area of this big square, which is x plus 3 square. All right, to find this area, it is actually this big square here, the area of the big square minus of area of the big square. Yeah, so I hope you get to see this particular pattern. So basically, it simply means x squared plus 6x. To find this area, it is the same as area of the big square minus of area of the small square. So throughout the next few examples, I will be using this, all right, to illustrate to you, and hopefully you can see the pattern. All right, how do we actually complete the square? Okay, so now let's take a look at another example. So over here, what I have is x squared plus 8x. Now, so if you can recall the earlier two examples, what I did was I simply split the 8x into 2. So therefore, I can rewrite this as x squared plus 4x plus 4x. Now to visualize it, so this is simply means I have area of a square, which is x squared, represented by the blue square, and then I have the area of 4x, right, which is length, which is x times 4, so this give me 4x. So likewise the other 4x will give me area of this. Yeah, so complete the square again, it simply means I need to complete this square. So in a way to represent is what is the area of this blue and the yellow area. So to do that, the big square here that I have is actually x plus 4 squared. Now, then, therefore, you notice that there is still this extra piece here, isn't it? So in order to find this area, so what I need is, I will simply need to subtract off the 4 squared. So what you observe is this number here, right, that you are dealing with, it is always half of the coefficient of x. Now, this is what we do when we actually represent it using diagram. Now, how about, let's say if we are going to use algebra method to work on it. Now, to use algebra, so what it simply means is that for me to make this into a complete square, I will need to add on a missing piece. And what is this missing piece? This missing piece is actually half of the coefficient of x. So in this case, it is equals to 4. So I need to add on with 4 squared. Now, if I write this 4 square here, add a 4 square, you notice that the first expression and the second expression here, these two are not equivalent at all. All right, there is an extra 4 square here. So to make these two expressions equivalent, what I need to do is I need to subtract away the negative 4 square. So what you realize, all right, is that these first three terms, all right, if I combine it together, all right, this will actually give me a perfect square based on, right, a square plus 2ab plus b square. So this gives me the perfect square x plus 4 square. And then with this negative 4 square, it remains. All right, so therefore I get minus 4 square. So hopefully by this, you get to see that using a visual approach to see, all right, you actually get the same expression as what we do, right, using the algebra method. All right, so these two are actually the same. So hopefully you get to see the relationship between the two. All right, we are going to explore further and help you to see the relationship further. Okay, so over here, I'm going to illustrate two more examples. So before we proceed, right? So by now, the important things that you must know that is that in order to complete the square, I will need this term and this term, which is equals to half of b squared. So whatever it is, I will need to take note of the coefficient of x and then I divided by 2. So two examples, I'm going to illustrate two different approaches. So the one on the left is the visual approach, and then the one on the right, I'm going to illustrate using the algebraic approach. All right, so let's begin. So using the using the graphical, the visual approach. All right, so what I'm going to do is I will have x squared plus 7 over 2x plus 7 over 2x. So basically, I split them into 2, right? So now what you can visualize is that this will give you area of the blue square, all right, the smaller square. And then these two will be area of the two rectangles. So in order for you to find this area, it is the same as I find, all right, area of the big square, and then I minus off area of the small square, and the small missing piece is actually 7 over 2 square. So this, all right, it is easily done by using the visual approach. Now, the other one, I'm going to use the algebraic approach. So using the algebraic approach, that means I will need to ask myself, okay, what is the term that I need to add in order to make this into a perfect square? So to do that, again, I need to make use of half of b, right? So that means the number here is negative 10. So therefore, to make it into a perfect square, I will need to add a term. This term is actually half of negative 10. So half of negative 10 will give me negative 5. So again, to make this two expression equivalent, I add a term. I have to subtract the same term so that the two expressions are equivalent. So to do this, now you will observe that these first three terms here, you combine, this will give you the perfect square, which is x minus 5 square. Yeah, and then the last term here remains, so I just simply write it down. So this is what I have, all right, after completing the square. Now, there's another important things for you to take note here. You notice that, right, the sign here is different. Right, over here, the second example is x squared minus 10x. So what I do want all of you to take note is that the moment if the sign here is negative, all right, the sign inside the bracket will also follow and becomes negative. So this is simply because of, if I expand this, right, x minus 5 squared, this will give me x squared minus 2a. All right, minus 2ab, and then minus of b squared. So it's actually from there. So over here, if you take a look, right, over here, the sign here is a plus. All right, so therefore, the sign inside the bracket is also a plus. So over here, I have additional things for you to take note. So not only just remember the half of b squared, you also need to take note of the sign. Okay, so let's do a quick summary of what I have gone through so far. So I have used two different methods to do completing the square, the visual approach and the algebraic method. Yeah, so what I'm going to do here is I'm going to use a visual approach. So in order for me to do completing the square, so what I'm going to do is I'm going to take note of the coefficient of x. So over here is a 4. So this is referring to area. So visual approach, so that means I'm using area of the big square and then minus of area of the missing piece. So likewise for the next one, x plus 6x, half of 6, that's give me 3. So area of the big square minus of area of the missing piece. Now over here for the other two examples, all right, you notice that the sign of the expression here is minus. So therefore, you notice that the sign inside the bracket, it is also minus. So again, area of the big square minus of area of the missing piece. So lastly, area of the big square, right, minus of area of the missing piece. So with this, I do hope that you're able to identify the patterns. All right, so these patterns here do have this key takeaway, that is half of coefficient of x and also follow the sign. So if I'm going to write down the generic form, all right, with x squared plus bx, so I will have x plus b over 2 square and then minus of area of the missing piece, which give me minus b over 2 square. Yeah, so again, all right, take note of the sign. So all these are very critical. So but whatever it is, you notice that, all right, for the missing piece, right, the sign here never change. So hopefully you are able to identify the patterns, and then if you're able to see this, then completing the square, it is actually not tough at all. So with this, I hope you find this video useful. All right, thanks for watching, and I will see you in the next video. All right, bye.